Welcome to the module on SIMIA reference properties. This is the first video in the module. Before we talk about the objectives for this module, I would like to mention that we're going to use the same example of the Subway restaurant that we have covered in several related modules. So in related modules, we talked about initial model development and its verification process. And also in the module on states, properties, and add-on processes, we extended the initial model by adding components such as bulking or conditional routing for different types of entities in our system. In this module, in the first video, we're going to talk about the need for reference properties, why we need them, and what they're used for. In the second and third videos, we're going to perform more experimentation with the Subway model by adding reference properties to our model. So in the second video, we're going to learn the first approach for defining reference properties by using the set reference property feature. And we will talk about side-by-side smart plots and how we can perform direct comparisons between different scenarios. In the third video, we're going to learn an alternative approach for defining reference properties directly from the Definitions tab, and we will perform more experimentation with the model. So as for the objectives, we're going to learn how to define reference properties to assign values to different object properties in our model. We will also learn about experiment controls and how we can define multiple scenarios in one experiment to perform comparisons. Specifically, we would like to evaluate different configurations of a Subway restaurant, and in order to perform comparisons, we will look at side-by-side smart plots. So we're going to talk about how we can interpret the results by looking at the side-by-side smart plots as a result of using controls in our experiment. The description of the system is same as before, so we have an arrival rate of 32 customers per hour, and you can see the service times here. 70% of the customers get their sandwich toasted, and 30% get cold sandwiches. Under the current policy, we need to maintain FIFO throughout the system. So, in other words, customers that want cold sandwiches cannot pass those that are waiting in the oven station to have their sandwich toasted. And also we have bulking, and whenever customers arrive, they'll look at the number in the system, and if there are more than 6 people in the system, they will bulk. So if I go back to our model that we built in the previous video modules, so you can see the general structure of the model here. So if I run the model, you can see that we have hot customers, those customers that get their sandwich toasted, represented by the red symbol, and cold sandwiches or cold customers represented by the light blue symbol. And as you can see, we have add-on processes that basically change the symbol of the entities when they're created based on their type. So if I go to my add-on process here, I have a decide step that is probability based, where I decide whether the newly created entity is of type cold or hot, and then based on that I assign the processing time on the oven station. So if my entity is, let me go ahead and stop the model so you can see the values that I assign here. So if my recently created entity is of type cold, which happens with a probability of 30%, the processing time on the oven will be 0. Otherwise, it'll be a random variable, triangularly distributed with the parameters specified in the problem statement. And we also assign the symbol for the cold customers by changing the model entity dot picture state and basically incrementing it. You can also see that we have another decide step that basically implements our bulking logic. So my decide step is condition based, and as you can see, customers bulk if the current number in system is greater than 6. So let me go back to my slides here. Um, so we're interested in evaluating the performance of the system during lunch rush, and specifically we would like to answer the following two questions. First, we would like to add 2 additional resources to reduce lost sales, and the question is where to put these 2 additional resources. So keep in mind that the resource can be either an oven or a new drink machine or a worker at any of these stages. The other question that we would like to find out is uh, what is the best operating policy under the new system configuration? Should we allow passing or just stick with the current no passing policy? The performance measures will remain the same. So we're going to use server utilizations, average time in system for all customers, expected number in system, percentage of customers that bulk in average time in system per customer type, in other words, cold and hot sandwiches. But we will primarily use the percentage of customers that bulk to compare different scenarios or system configurations. So how do we answer these two questions using simulation? Well, what we basically need to do is evaluate different system configurations under the two policies that we have. In fact, if we would like to find the optimal uh, system configuration and policy, we need to evaluate all possible scenarios. So when you think about this particular problem, we would like to pick 2 out of 5 stages for capacity expansion purposes. So basically we have a selection of 2 out of 5 options, which gives us 10 scenarios. And since we have 2 operating policies, we have a total of 20 scenarios that we need to evaluate using simulation. So perhaps the most basic approach is modify the model 20 times for our 20 different scenarios and run an experiment for each scenario. So for example, I can go ahead and change my capacity for the first stage from 1 to 2 and my oven capacity also from 1 to 2. And now I need to run an experiment. So here is my original experiment with all server capacities set to 1, and as you can see I have a percentage of bulkers of 9.88. So I'm going to duplicate my experiment so I won't have to redefine my responses and set the rest of my run configurations. And I'm going to rename this scenario scenario 1. So now if I run my model, I'm basically running my first scenario where I have 2 units of capacity at the first 2 stages. So now my experiment is complete and I can go ahead and compare my different performance measures with the original model. So for example, let's look at the bulking percentage after adding the 2 resources. So here we have a bulking percentage of 8.70, whereas originally we had a bulking percentage of 9.88. So what I can do now is repeat this process 20 times, so basically modify my capacities 20 times, and every time I need to run an experiment and compare these results together. But as you can see, this process can get very tedious when we have many possible scenarios. It would be really nice if there was a mechanism that would allow us to simultaneously compare multiple scenarios using only one experiment. And in fact, Simio has this feature, and in order to use that feature, we need to learn about reference properties and experiment controls. One thing that I would like to add here is that we could also look at the SMORE plots. So for example, for my first scenario that where I have 2 units of capacity on the first 2 stages can go to my experiment and response results and look at the SMOR plots, and particularly I would like to look at the SMOR plot for bulking percentage. And in order to compare my SMOR plot with the original model, I need to go back to the experiment for the original model and then go to the corresponding SMOR plot for the bulking percentage in the original model. And as you can see, the problem is that we really cannot make a side-by-side comparison, which is what we would really like to do here to compare different scenarios. So I can switch back and forth between the two experiments, but I can't make a side-by-side comparison when I have separate experiments for different scenarios. So let me go back to my slides and talk about referenced properties. So a referenced property is used to specify the value for an object property, just like any other property that we have in our model. However, they have a specific functionality which allows us to facilitate experimentation with multiple scenarios all in one experiment. So in particular, if we set a reference property to appear as what we call a control in our experiment, then as you can see in this figure, we will be able to run multiple scenarios in one experiment and perform a simultaneous comparison. So as you can see in this figure, I have the capacity of the server set as reference properties and also as controls in my experiment. So I can easily change the capacity. So for example, in my scenario 1, I have 1 unit of capacity at bread, 2 in the oven, 2 at veggies, 1 at cashier, and 1 at drink machine. And I have defined multiple scenarios by changing the capacity levels. So when I run an experiment like this, I basically run all these scenarios simultaneously, and I will be able to compare the results without having to define multiple experiments. And we will talk about this and how we can set reference properties and use controls and perform side-by-side comparisons in the rest of this module.